Assalamu alaikum, dear students. Yesterday we discussed the geometric sequence and the sum of the n terms of the geometric sequence. Now, today we will be discussing the geometric mean, that is GM. Now, if a and b are two positive numbers, here the condition for these two numbers is that these two should be positive. Then the geometric mean of a and b, that is given two numbers a and b, is the number equals to root a into b. That is, geometric mean between any two numbers is number which is equals to square root of a into b. Here a, root a, b and b, it forms a sequence. These three numbers forms a finite sequence. Now we will check whether it is GP or not. Here first term is a, that is a1 is a, second term is a2 is root a b, and third term is b, simply b. Now second term upon first is root ab upon a. Now this a can be written as root a square, because square and root cancels, we simply get a. Cancelling root a from numerator and denominator, we simply get root b upon root a, that is root b upon a. So the common ratio for these two terms, that is the ratio for these two terms, is root b upon a. Similarly, a3 upon a2, that is b upon root ab, b can be written as root b square. So cancelling one root from numerator and denominator, we get root b upon root a, that is root b by a. So this means that the geometric mean between a and b is root ab, and the sequence agm, that is geometric mean between a and b, forms the geometric progression or the geometric sequence. Like if we consider a equals to 2, b equals to 18, then the geometric mean between these two numbers is root ab, that is root 2 into 18, which is root 16, that is simply 6. Here this sequence 2, 6, 18 is always in geometric progression, that is, it is always geometric sequence. Now inserting, like if we insert, if in this arithmetic progression we insert n numbers between any two numbers, such that given sequence becomes arithmetic progression. Here we will also insert this n numbers between these two numbers, between given two positive numbers, such that the resulting sequence becomes geometric sequence. Let g1 to gn be the n numbers between these two positive numbers a and b, such that the given sequence becomes g1 g2 gn up to b. Here we have how many terms? That is n plus 2 terms, because a and b are 2 and we are inserting n numbers, that is we have n plus 2 numbers. Let a be the first term, it is given a is the first term, and r be the common ratio. Then the last term, that is a n plus 2, is b, and we know that for gp, whose first term is a and r is the common ratio, nth term is a r raised to power n minus 1, which is a r raised to power n plus 1, because b is n plus 2th term, which implies that r equals to b upon a raised to power 1 by n. So this means that if we have to insert n numbers between any two numbers, such that the resulting sequence becomes gp, then we have to put common ratio as b upon a raised to power 1 by n plus 1. Now here a2, second term of this gp, is g1. It is ar, because ar is second term of gp, which is a into b by a, because r is this b by a raised to power 1 by n plus 1. Similarly, a3 is g2 equals to a into b by a raised to power 2 upon n plus 1. Similarly, a n plus 1, n plus 1th term is gn, which is a r raised to power n minus 1, which is a into b by a raised to power n plus 1. Sorry, here it is a or n, because gn is n plus 1th term. So by inserting n numbers between two numbers a and b, such that the resulting sequence becomes gp, we have to put or take the common ratio as b by a raised power 1 by n plus 1, and those n numbers which we are inserting between two numbers, we have to put those numbers as gi equals to a into b by a raised power I by n plus 1, where I equals to 1, I equals to 2, I equals to 1 to I equals to n. This means that this sequence, when we put r equals to b by a raised power 1 by n plus 1 and gi equals to a into b by a raised power I upon n plus 1, then this sequence a, g1, g2, gn equal b becomes gp. So this means that while inserting n numbers between any two numbers, we have to put those numbers as gi equals to a upon b by a raised power I upon n plus 1, where n is the number of terms we are inserting. Like if we consider two numbers, positive numbers, a equals to 3, b equals to 81, we have to insert two numbers between this 3 and 81 so that the resulting sequence becomes gp. Now here first term is a is 3, b is 81. Let g1 and g2 be two numbers uh, between this 3 and 81 so that the resulting sequence a, g1, g2, 81 becomes gp. Here we are inserting two numbers, which implies that n is 2. We know that while inserting n numbers between a and b, we have to put those numbers as gi equals to a into b by a raised power I upon n plus 1. N is here 2, which implies that gi is 3 into 81 by 3 raised power I by 2 plus 1, which is 3 into 27 raised power I by 3. Now g1 becomes, by putting I equals to 1, is 9, because 27 is actually 3 raised power 3, and 3 raised power 3 raised power 1 by 3 is simply 3. Similarly, g2 is 27. So clearly this sequence 3, 9 and 27 are the two numbers which we are inserting, and 81 is the last number, is gp, because 9 by 3, second by first, third by second, fourth by third, the ratio of these three terms is 3. Hence g1 equals to 9 and g2 equals to 27 are the required numbers which we are inserting, or which we have to insert between 3 and 81 so that the resulting sequence becomes gp. Inshallah, in tomorrow's video lecture we will discuss the relation between the geometric mean and the arithmetic mean. So thank you.